Everyone, here is Roberto Santos, and this is the last part of our first training about HydroML. So far we have seen what is the context for the HydroML project, and we went through creating projects using the rainfall type of project, upload data sets for training, set up the configuration for the data sets, the parameters for the machine learning method that we are using, the random forest for rainfall data. We run the models, we train the models, and then we saw how to test the prediction by uploading a small data set to visualize the prediction. Okay, on this one we are going to create a new type of project. So I'm going to hit the new project. Okay, and this one is going to be I'm going to call this São Luís. This is my non-existing hydrological station for training purposes. Okay, we're gonna choose the type, and then we're gonna use the water level. Okay, we're gonna use the standard delimiter for the CSV files. Just remind you that all the training data sets must be provided in the CSV format, and I'm gonna choose the file here. Okay, I'm gonna choose this water level data that I have defined before. I'm gonna show you quickly what's the contents of these files, this file. So we have water level, and water level basically comes with 3 columns. Okay, we have the timestamp, that's the date time column. We have the measurement, that's the measured column, and we have a label. If you have seen the previous video, there is a slight difference between this format and the format for the rainfall. This is because the type of algorithm that we are using for each one of these types of projects. With rainfall data, we have been using random forests, and there we analyze the data row per row, and each row must contain all the information that we need to assess the measurement on that particular row. Okay, that means that in the context of the rainfall data, we are looking for the data of where the stations around the target station, so our neighbors, and I have to provide the values of those of the measurements in those on those stations around the target one at the same time stamp. With the water level type of project, we are using the LSTM algorithm for training the machine learning models. And the LSTM is a slightly more robust or complex method that doesn't need the input to be as well structured as the one for the random forest. The meaning here is that we can provide the data as it is here, and the random forest, the LSTM method is gonna try to find the structure in this data set without us informing, for example, that a particular value is the neighbor of is coming from the neighborhood. Okay, all right. So that means that for water level data, the training files and the data that you're going to send for the prediction, it's usually much simpler. Okay, basically 2 columns in the training, 3 columns, timestamp, measurement, and the label. For the prediction, it's basically timestamp and the measurement. Okay, so I just chose that file, water level data. I'm going to hit next. Let's give it a second. As with the rainfall data, the next step is the hyperparameters, the parameters that we use in the LSTM algorithm. Here we have the batch size and the epochs. I'm going to use the standard ones. Batch size equals 1 and epochs equals to 150. I'm going to hit next. Then I need to identify what my columns are, how they map to the features. So the date time is my timestamp column, the measured is my input column, and label is my target column. And I don't have anyone that I need to that I'm gonna skip in this example. I'm gonna hit save here. We have the new station, the new project called São Luís. Okay, I'm gonna click on São Luís. We can visualize the data. So if I click on chart, we should see the water level, and you can see here some spikes that could be potentially or a natural event like too much rainfall leading to a raise in the level of the water, or might be a problem in the data. We can see the data in the table format here. We can revisit the features, and we could adjust if we have any changes. We can revisit the hyperparameters. Same thing with the labels, and finally you can go to the models. Okay, and as we did with the rainfall type of project, I can hit training model, where I can again see all the parameters and we can adjust them. I'm gonna hit start training. Slightly different from the random forest. The training of the LSTM takes longer, and depending on the type of the size of the training data set, it can take from many minutes to hours of running. Okay, I chose a small data set so that we could run this in the time span of this video. We're going to go back to the modules. You can see the training is still running. I'm gonna pause the video for a second and come back when we have the training ready to go.